Hi guys, Miss Malik here. I've kind of got my voice back a little bit, so that's good. Today we're going to look at exercise 3H, determining the rule for a function of a graph. This isn't too bad compared to some of the other stuff we've done. So an example would be the following. It is known that the points 1, 5 and 4, 2 lie on a curve with the equation y equals a of x plus b. Okay, so we want to find the values of a and b and hence state the equation of the curve. Now, all we need to do, we've got 2 points, so let's substitute those points into the equation y equals a over x plus b. So it would be 5 equals a over 1 plus b, and it would be 2 equals a over 4 plus b. Now be careful, it sounds silly, but some people, quite often in exams and SACs, people will accidentally mix around the x and y values, particularly when it's something a bit more complicated. Now, when we are trying to solve for a and b usually, we would use simultaneous equations. So all we have to do is subtract the two equations. So I'm going to do that, and this is using the elimination method in order to solve. So what I end up with is 3, because 5 minus 2 is 3, equals 3a on 4. Now, from that, I can work out that a equals 4, and, well, to find b, I can substitute into one of my equations. So if I substitute 4 for a into the first equation over here, I get 5 equals 4 over 1, which is 4, plus b. So solving for b gives me b equals 1. Now, you may have wondered where I got this 3a from. Remember that you're going to have to, when you add and subtract fractions, you have to find the common denominator. So I had a over 1, I make that into over 4. So 4a over 4 minus a over 4 would give me 3a on 4. I then want to state what the actual equation would be now that I know what a and b are. So quite simply, I substitute a and b, 4 and 1, into my original equation y equals a over x plus b. So it's y equals 4 on x plus 1. Not too bad. So yeah, just don't forget to actually state the values of a and b and also state the equation. You may wish to highlight that in your solutions. Let's do another one. Again, not too difficult. So it's known that the points 2, 1 and 10, 6 lie on a curve with the equation y equals a square root of x minus 1 plus b. Once again, let's just substitute those points in because we want to find the values of a and b. So the first point being making 1 equals a root 2 minus 1 plus b, and the second one being 6 equals a root 10 minus 1 plus b. Once again, I just subtract those because by subtracting them, I can eliminate b. So notice how b, it's plus b here and it's plus b here. So by subtracting them, you get rid of b. Be careful because it won't always be subtract. If that was a negative b here, you'd have to plus it so that you get b or plus b minus plus b, or plus minus b rather. So be careful of that. Once again, we can just use the elimination method. So we end up with 5 equals 2a, and therefore a equals 5 over 2. How I got 5 equals 2a, just to be sure people understand that, I solve this root here. So 2 minus 1 is 1. So it gives me 1 equals a plus b, and then here I get 6 equals 10 minus 1 is 9. So I get 3a plus b. So 1 minus 6 is minus 5 equals, so a minus 3a equals negative 2a, and we've eliminated the b. So therefore, you know, the negatives, we divide negative by negative, gives us a positive, a equals 5 on 2. We then substitute that into one of the equations. Doesn't matter which one you use. I've used this one because it's just, well, it's slightly easier there. So that gives me b equals neg 3 on 2. And I'll just substitute those values in a and b into the original equation of y equals a root x minus 1 plus b. So I'll substitute 5 over 2 for A and neg 3 on 2 for B. And that's it. Definitely not too bad. Let's just do one more. This exercise is really short. Here I think there's just a total of 6 questions. This is question 6. So it says the points with the coordinates neg 1, neg 8 and 1 and negative 2 lie on a curve which has the rule of the form y equals a on third root of x plus b. Once again, we want to solve for a and b. We've got 2 points. Easily done. So let's substitute in the first point. Neg 8 equals 8 over, or a, sorry, not 8, over third root of negative 1 plus b. Negative 2 equals a over third root of 1 plus b. So they're the 2 points substituted in. And notice that the third root of negative 1 will be negative 1. So a divided by negative 1 is negative a. So we're going to get negative 8. Well, first we're going to eliminate in a minute. So we get negative 8 equals negative a plus b. And over here, a over the third root of 1 is 1. So negative 2 equals a plus b. We're using the elimination method once again, so I subtract the 2 equations. Gives me negative 6 equals negative 2a. Solving for a equals 3, substituting a into one of the equations there, so a being 3, and I end up with b equals negative 5. Let's put those into the original equation of y equals a over third root of x plus b, giving me y equals the third root, y equals 3 over the third root of x minus 5. And that's it. That's the end of 3H.